The second report concerned geometric methods of analysis on three-dimensional manifolds, which became especially popular after the proof of point conjecture. And it's my pleasure to introduce our regular conference participant, doctors of science from Kharkov, Dmitry Bolotov, with a report on the topic of dual Thurston norm and Euler classes of foliation on closest three manifolds. Please.
Thank you very much. It's a very pleasure to give a talk here. So let me start from the problem which I deal with. Let M3 be oriented three-dimensional manifold, and F is a codimension one foliation on three-dimensional manifold. It means that our manifolds is have been represented as disjoint sets F alpha, such that the set looks like locally as a family of planes, parallel planes. As our manifold is Riemannian, the metric is induced on each leaf. Each connected component we will call leaf of this foliation. And we can consider also a second fundamental form on the leaves, and we say that foliation is stout if all leaves are minimal submanifolds locally minimal for some Riemannian metric on M3. If we consider tangent distribution to our foliation, then we have the following result by Thurston. The Thurston dual Thurston norm of Euler class of this distribution not more than one. In particular, this means that for if actually this Thurston norm is not norm, but on some Riemannian manifolds is really norm. In this case, we have that only finite many classes of two-dimensional cohomologies can be realized as an Euler class of such foliation. What is a taut foliation? What is the problem which I consider? Let us consider class of foliation for which the mean curvature as the module of mean curvature of leaves is bounded from above by some constant. And the question is following: can we find the estimation from above on the Thurston norm of such foliation? This question has a positive answer in the case when M3 is hyperbolic or have a sectional curvature less than 0. And we can find constant which depends on such constant from H0 from the limit constant for sectional curvature of our manifold, and for volume and injectivity radius of M3, injectivity radius. Okay, let us move to the next next story. Okay. Let us let me recall that first cohomology, the group of first cohomology, is isomorphic to the homotopic classes of mappings to the circle, and each cohomological class can be represented as an image of the generator of first cohomology group of the circle. Let us recall that we have the Poincaré duality between the homology and cohomology groups, and recall also that the first cohomology group doesn't contain Thurston elements, and we can consider such group as a subgroup of first cohomology group with the real coefficients, and these classes are just integer lattice in the vector space H1 with the real coefficients. Observe that the Poincaré duality induced the Poincaré duality of integer lattices. Okay. Let us identify the circle with a unit length circle, and theta will be a natural parameter. If f is a smooth function, let me recall that in each homotopic classes of mapping to the circle, we can find a smooth function. And if f is a smooth function, then the preimage of regular value is a smooth oriented, not necessarily connected manifold, submanifold, and it is just a dual by the Poincaré to the class, which is to the class A. Recall also that in each homotopic classes to the circle, we can find so-called harmonic mapping. Harmonic mapping, it is such a mapping that minimizes the such functional. This is important for us. For example, the image of if we consider the generator in cohomology group as represented by the volume form on the circle, the image of this class in cohomology in first cohomology group of our manifolds is just a harmonic one form. Here I identify the Dirac cohomology and cohomology with real coefficients. It's well-known theorem. Okay, in the space of differential curve forms, one can introduce L2 norm like this. Here, star denotes the Hodge star operator. We can observe that three-dimensional vector space in three-dimensional vector space, each curve form is a symbol, and we can understand module alpha p as a maximum of alpha p over all orthogonal frames. That is coincide with the so-called co-mass norm. And we can introduce also L infinity norm as a max like this. Okay, and this norm on the forms can be we can induce the L2 norm on the Dirac cohomology as following way, as the infimum all for all forms, L2 norms on forms. From Durham-Hodge theory, it follows that the L2 norm, defined like this, is just a norm of harmonic form representing this class. I recall that for cohomology, for that harmonic form can be defined as by these two equalities, where delta is conjugate to the D. Using Poincaré duality, we can introduce L2 norm on homology group by the following way, and from another hand, the non-generated Kronecker pairing of homology and cohomology with the same indexes induced a dual norm on the cohomology. But Bengard and Gatz have shown that the Poincaré duality just is an isomorphism between the cohomology which we defined and cohomology and group cohomology with dual norm. Like it's true, just if we replace L2 norm to L infinity norm. Even if we change 2 by P, and here we should write Q such that 1 by P plus 1 by Q equal 1. Okay? Let me now define what is a Thurston norm on two cohomology. I can remark that I want to remark that the norm, this norm on cohomology depends on the metric, remaining metric on three-dimensional manifold. The Thurston norm doesn't depend on the metric and define the following way. Firstly, we define the Thurston norm on homology, on two homology group, as following. It is the infimum of G minus from sigma. The sigma is embedded surfaces representing class A. And G minus is just a minus Euler characteristic, and if sigma torus are two-dimensional sphere, it is just 0. Recall that the Euler characteristic is 2 minus 2g. The g is a genus of sigma. If sigma is not connected, then we should take this following sum. Okay. actually, this norm is called norm, but this is not norm. It is only a semi-norm. But in the case when M3 is irreducible and toroidal oriented Riemannian three manifolds, for example, M3 is, for example, M3 is three manifolds of negative curvature. This is an example of such manifolds. Then Thurston norm is actually norm. And in this case, we can define and correctly define dual Thurston norm by the following way, standard way. So let me recall that dual Thurston norm is not more than one. For the in the case of tau foliations, the Thurston norm of error class of tangent distribution to the tau foliation, the Thurston norm is no more than one. We can define a Thurston norm on one cohomology setting by Poincare duality. The following theorem belongs to Stern. Stern proved that if U is harmonic map, then we have the estimation from above by the L2 norm, the Thurston norm. He proves the following. In some sense, this is average Euler characteristic. Okay. This is very useful for us, this result. What is R minus? R minus is a negative part of scalar curvature R on our Riemannian manifold. Let me recall why it is important. A similar estimate was obtained by Kronheimer and Mrovka for the dual Thurston norm on two cohomologies of irreducible toroidal three manifold, and he proved the following. Moreover, he proved that dual Thurston norm is just a supremum if we over all Riemannian matrix on M. That is just a supremum of such and Kronheimer and Mrovka introduced so-called monopole classes, which very connected with the physics and three-dimensional Zabel-Witten theory. And they proved that for these classes we have such estimation, because it is very important to this matter. Okay. So the next slide describe so-called systole. What is a systole? Let us introduce the systole as following. Systole is defined as a minimal norm of the non-zero lattice vector. But the norm should be take the L infinity. The geometrical sense of systole explained Federer Federer shows that if vol 1 of H denote infimum of the remaining volumes of all integer 1 cycles representing H, then HR R with a star infinity is just such limit. The following very important Bazanchuk theorem. Let us consider bidimensional norm real vector space and lattice. In particular, rank L is B. Then for each E, we can denote minimal lambda for which there exist E linear independent vectors with no smaller or equal lambda. Let L star denote a lattice dual to L in the dual space. Then we have the following inequality, where R A is a constant, B is a dimension of our vector space, and this is also is very important.
Dima, 1 minute left.
Huh?
1 minute left.
Let me formulate our theorem, which we proved in 2024. If we consider such constant, which bounds the volume, sectional curvature, and injectivity radius, then we can estimate the Euler class of foliation by L2 norm from above by the sum constant. And main theorem of my present work, if we include to this constant also first stable system, and we suppose that stable system is more equal constant S0, then we can find some constant that such that the Thurston, dual Thurston norm of such foliation with such estimations by this constant no more than equal this constant. And sketch of proof using Banachuk theorem, Stan theorem, we can find my estimation, which we have obtained. Okay, thank you very much.
Thank you for your talk.